Hello, Eagles. Um, Today we're going to start our next unit, kind of our last unit of the year, which is over circles. We just finished up our unit over congruent triangles and being able to identify different triangle congruencies. So, the last few weeks of school, we're going to focus on circles and different properties of circles. First thing I want to review is the basic part of a circle that hopefully we already know. First, we have circles. Circles are an equal distance from a center point. The center point is the label of the circle, so we would call this circle A. We have a radius, which goes from the center to a point on the outside of the circle. We have a diameter, which goes all the way through the center of the circle. We should know that the diameter is 2 times the radius, or the radius is half of the diameter. We also need to recall that a circle has the circumference, which can be found by doing pi times diameter. A lot of times in Math Excel, you may see the term, the answer to be in terms of pi. All that is saying is leave your answer with pi as the pi symbol. Don't input 3.14. So an example of in terms of pi, if we wanted to find the circumference of a circle that has a diameter of 10, our circumference would just be 10 pi. That's in terms of pi. We are not replacing 3.14 for pi. We're leaving it as the pi symbol, which we all know is an irrational number that goes on forever. So those are some basic parts of a circle that we have to remember. To start our unit of circles, we're just going to look at how to identify some other parts of a circle, known as arcs and inscribed angles. So as I put another circle here, let me identify the center of this circle. So we have a radius, and if we have two radius that meet at the center point, it creates an angle. That is an inscribed angle. It also creates an arc, the outside part that connects the two radius. We have two types of arcs that we talk about. One is a minor arc. The other is a major arc. A minor arc is any arc that's less than 180 degrees, which is a semicircle. Think about cutting the circle in half. That's a semicircle. So any arc that's less than a half circle is a minor arc. Any arc that's greater than a half circle is a major arc. So we could label this arc, we would say this is arc BC. And because it's less than half the circle, it's a minor arc. We could label arc BCD, which is this arc here, and that's a major arc because it's greater than the semicircle. But we could also have mark arc BD, which goes this direction. Now that's a minor arc. So this center point C is important to tell whether I went clockwise or counterclockwise. So sometimes your arc could have 2 points on it. Sometimes you would have 3 based on if you need to determine whether you're going clockwise or counterclockwise. Finding the measure of an arc. Get another circle out here. So if I have my center, my 2 radius drawn, creating my angle, and then this creates the arc, and we'll call this A, B, C. We want to find the measure of arc BC. And it's really this simple. You have to know what the angle measure is. If I tell you the measure of angle A here is 92 degrees, the measure of arc BC is equal to the measure of this angle BAC. So therefore, the measure of arc BC would be 92 degrees. Really meant that simple. The arc measures the same as the inscribed angle, the interior angle that's created by the 2 radius joined together. No tricks to it. That's simple. As long as you know the measure of the angle, you can identify the measure of the arc. And you could go vice versa. If I tell you the measure of arc CD is 89, that's enough information to tell that that is 89 degrees. They measure the same. All right. Hopefully pretty simple so far. And the last part of this screencast, which you'll have 2 of them this week, is going to be finding the length of an arc. Now, this is going to be a little more challenging as far as compared to what we've just talked about. Finding the length of an arc is a little different. So if I have my arc and again, we'll call it ABC. So I want to find the length now. It's like finding part of the circumference of a circle, the length between B to C. It's different than the measure of the arc. The measure of the arc, as we said, is the same as the measure of the inscribed angle. So to find the length of the arc, we need to know this formula. The measure over 360 times pi times diameter. And that's how we will find the length, the distance of this arc. The measure here is what we just talked about. It's the same as this angle. So if I said angle A measures 45 degrees, the measure of BC is 45 degrees. We're going to need that information to find the length of this arc B to C. To find the length of arc B to C, I would plug in my measure, which is the same as the angle, over 360 times pi. And then we also have to know the diameter. So let's say the diameter of this is 16 times the diameter of 16. And again, if we only knew the radius, the diameter is 2 times the radius, and we could use that information as well. Now, let's go back to our in terms of pi. If we're doing it in terms of pi, we don't input 3.14. So we would simply do our 45 over 360 times pi times 16. So you could really just go to Desmos and put in your calculator that fraction, which is what I'm doing right now. 45 over 360, and then times the diameter of 16. And because we're leaving it in terms of pi, we don't really have to worry about that. And we would get 45 over 360 times 16 is 2. So the length or the of arc B to C is 2 pi. If we weren't finding it in terms of pi, then you would simply plug in 3.14 for pi, and we would get 6.28. All right, and that's again finding the length of this arc, which is different than the measure of it. Kind of threw a lot of information in there. You may want to watch it twice. Be sure you're taking notes. You may have to look up some extra definitions and email your teachers with questions. And then there will be a second screencast for this week as well.